Hello, hi guys. Today we will discuss Zeeman effect. What is Zeeman effect? What are the importance of Zeeman effect? Okay. Now, before discussing Zeeman effect, in 1896, Zeeman discovered that if source of light producing line spectrum, suppose a source of light producing line spectrum, if there are line spectrum which is in straight line, okay, is placed in very strong magnetic field. Suppose a source of light producing line spectrum and that line spectrum is very strong in magnetic field. At that time the line spectrum or spectral lines are split up into components, just like doublets or triplets or more, okay, more complex arrangement. This is called Zeeman effect. The statement of Zeeman effect, okay, if in your exam ask for 2 marks what is Zeeman effect, you can write if source of light producing line spectrum it's placed in very strong magnetic field, the spectral lines are split up into components, doublets or triplets or more complex arrangement. This phenomenon is called Zeeman effect. Okay, there are two types of effect proved by Zeeman, that is normal Zeeman effect and anomalous Zeeman effect. Simply, if you are going to remember what is Zeeman effect. Zeeman effect is a beam of light where the spectrum of line where in a magnetic field and the splitting of that spectral line in two or more, 2, 3 or more complex components. At that time we call it Zeeman effect. There are two types of Zeeman effect: normal Zeeman effect and anomalous Zeeman effect. In normal Zeeman effect there are 3 spectral lines. Okay, in normal Zeeman effect there are 3 spectral lines, and an anomalous Zeeman effect there are 4 spectral lines. You can simply remember that. Okay, now normal Zeeman effect. What is normal Zeeman effect? The statement of normal Zeeman effect is the splitting of spectral line. The splitting of spectral line into 3 components in a magnetic field when view in a direction perpendicular to the magnetic field is called normal Zeeman effect. Suppose a spectral line splitting in 3 component. Okay, suppose one spectral line and we have splitted it into 3 component in a magnetic field. Okay, there are many magnetic fields. Okay, at that time the view of that direction, the view of that magnetic field or spectral lines is perpendicular. The direction of that spectral lines is perpendicular to magnetic field is called normal Zeeman effect. Consider, just show in figure, this is spectral line and we are splitting in 3 components, and this one is perpendicular. Okay, the direction of perpendicular. So this phenomenon is called normal Zeeman effect. Normal Zeeman effect is obtained from source of the element like Ca, calcium, cobalt, zinc, cadmium, CaCu, zinc and cadmium. Okay. This normal Zeeman effect is obtained from that four elements. Okay. So in this normal effect, the substance emitting a line spectrum is placed. A substance emitting line spectrum is placed in a magnetic field. Its lines split up into number of closely spaced. Okay, these are the closely spaces. Okay, now we will discuss anomalous Zeeman effect. What is the statement of anomalous Zeeman effect? Okay, when a single spectral line is split up into 4 or more lines when observed in a direction perpendicular to that magnetic field is known as anomalous Zeeman effect. Simply, if we are going to remember what is anomalous Zeeman effect, a single spectral line splitting into 4 or more components in a view of direction perpendicular to that magnetic field. At that time we called it anomalous Zeeman effect. The difference in between normal and anomalous Zeeman effect is, in normal there are three spectral lines. The splitting up of spectral line is three component, and in anomalous Zeeman effect the spectral line can be split into four or more component. Okay, and anomalous Zeeman effect is obtained from Na, sodium and Cr. Okay, just take an example of D1 and D2 are two component of sodium. Okay, yellow doublets give 4 and or 6 lines respectively. Okay, this is the figure shows that anomalous Zeeman effect. This is spectral line splitting into four components, that is sigma, pi, sigma. Okay, this is in the magnetic field, and there is no magnetic field. Okay, this is spectral line splitting into 6 component, that is sigma, pi, and pi, sigma. So this phenomenon is called anomalous Zeeman effect. Also there is in anomalous Zeeman effect a fine structure of multiple spectral line, however show a complex Zeeman pattern. Okay, so this is the anomalous Zeeman effect. Now we will discuss what is the importance of Zeeman effect, why it should be discovered by Zeeman. Okay. According to the atomic theory of Bohr's and Sommerfeld atomic model, he could not be explained by Zeeman effect, but nowadays Zeeman effect is very useful because the Zeeman effect has helped physicists to determine the energy levels of atoms. Zeeman effect is used to determine the energy levels in atoms and identify their angular momenta. And Zeeman effect also provide an effective studying atomic nuclei and such that the phenomenon of electronic paramagnetic resonance. Zeeman effect is also used to measure magnetic field of suns and stars. It is also used in astronomy. Okay, if you are now in astronomy, we are going to measure magnetic field of suns and stars. These are the importance of Zeeman effect. That's why Zeeman effect nowadays very important for us. Okay, and Zeeman shift is nothing but that is dy. If you are going to apply any force on Zeeman shift, then Zeeman shift is denoted by dy. That is the expression for Zeeman shift is dy is equal to plus minus b lambda square upon 4 pi mc. This is Zeeman shift d lambda is equal to plus minus by lambda square upon 4 pi mc. Okay, this is the Zeeman effect. Okay, in net exam net or set exam, Zeeman effect is very important, in which the question is asked for how many spectral line can be split up into anomalous Zeeman effect. Okay, this type of question asked for in net or set exam, and what is on and in normal Zeeman effect there are how many spectral lines can be split. So this type of question asked in net or set exam. If you like this video, please share to needful person, and thank you.